Good afternoon, students. I will start with the class. Yesterday we were solving problems on simplification, okay, on inverse trigonometry to simplify and then find its derivative. So 4 problems we had solved, 5 I think. So this will be the 6th one. Tan inverse of cos 3x minus sin 3x upon cos 3x plus to be y. Now, first we have to simplify because directly you can't take derivative of this tan inverse of something complicated over here. So in inverse trigonometry, we are under simplification, whenever there is a combination of cos and sine, we know that we have to try to make this fellow in the form of what? 1 minus something upon 1 plus tan theta. Okay, this formula 1 minus tan theta upon 1 plus tan theta form you have to bring. So in order to make this one, you have to divide numerator and denominator by cos 3x. Okay, so divide numerator and denominator by cos 3x. So this will be, when you divide, all the terms will get divided by cos 3x. So this will be 1. Sin 3x upon cos 3x will be tan 3x upon, same way, 1 plus tan 3x you will get. Now the formula is 1 minus tan theta upon 1 plus tan theta is nothing but tan of pi by 4 minus theta. This is minus, that will be minus. So y is tan inverse tan of pi by 4 minus theta. What is in place of theta? Nothing but 3x. So this will be a 1 minus tan theta upon 1 plus tan theta is tan of pi by 4 minus theta. If this was plus, this had to be plus. Now tan inverse, tan will cancel. So y will be equal to pi by 4 minus 3x. And now you take the derivative. Find dy by dx. Okay. What will be the answer? How much are you getting?
-3.
Yes, minus 3. Because when you take derivative, dy by dx, pi by 4 is a number. It's a constant. So answer will be 0. Minus derivative of x is 1. So answer will be minus 3. Okay. So 7th one. Okay. Tan inverse of 1 minus cos 2x upon 1 plus cos 2x. So first simplify and then find a derivative. So use the formula 1 minus cos theta is how much? And 1 plus cos theta is how much? So 1 minus. Minus means I told you always sine, and plus will always be cos. 2 sine square. Already double is there. 2 is there, so it will become 1. If this was only x, it would become x by 2. This is double already. And this will be 2 cos square x. And now cancel and simplify. So 2 and 2 will cancel, and sine square x upon cos square x will be 10 square x. And then if you take root, square will go and it will be a single 10 of x. And then it will cancel with this 10 inverse. And then you differentiate. So this will be like this. Then root and square will cancel. 10 inverse, 10 will cancel. So y will be x, and then take the derivative. So dy by dx will be 1. Okay, so these are some typical problems like this form. 1 minus cos, 1 plus cos. So you have to remember this formula. What is 1 minus cos theta and 1 plus cos theta. 8th one, sec of cos inverse 8 upon x. Can anyone tell me what is to be done?
Triangle.
Oh, one option is triangle, or one more option is there.
We have to shift the
This,
x in the
yes, shift the x means what? You can make it reverse, because I told you x is at the denominator over here. So whenever x is at the denominator, you can always reverse. So when you reverse it, it will become sec inverse. So this will be y you can consider. And then sec inverse will cancel. Okay, when you'll get a hint not to use this, it will be ulta. X will be here, and sec and cos are always related. So make it reverse. This will get simple. So x upon 8. Now find the derivative. So that will be 1 upon 8. Okay, so these were some examples on simplification. Now we'll do some few problems on substitution. based on substitution type inverse. Okay, so first one, the questions will be find dy by dx. Sine inverse two x root of 1 minus x square it is. So now if you check, I had given some standard substitutions, okay, in the inverse trigonometric functions. Even though if you have forgotten, if it is in the form of a square minus x square, it is sine theta. Okay, 1 plus x square, then tan theta, x square minus 1, then sec theta. Then suppose root of 1 minus x or upon some combination 1 plus x, it will be cos theta. Okay, so these were some of the standard substitutions. 1 minus x square and sine theta, plus means tan, ulta x square minus a square will be sec, and if there's a root with some 1 minus x and all, so that you have to put as cos theta. So this will be the standard substitutions. So if you notice here, it is in the form of 1 minus x square. Okay, so what you have to do is, you have to take, let x be equal to sine theta, you have to substitute. So whenever you are doing substitution, just find theta also and keep later on to substitute. So what it is, sine inverse x is equal to theta. Sine, if I bring this side, it will become sine inverse. This is for what? Last substitution. When you get answer as theta, you have to again write it back in terms of x. So that's why I just find it first only and keep. So now write the function again, but everywhere instead of x, you have to put it as sine theta. So this will be so this is x square. So what will happen? Sine square it will become. So root of 1 minus sine square theta. And what is 1 minus sine square theta? Cos square theta. Then again, root and square will cancel, and this will become sine inverse sine theta cos theta. And yesterday only we had done that formula. What is 2 sine theta cos theta? So that was what? Sine 2 theta. 2 sine theta cos theta is nothing but sine 2 theta. So y will be sine inverse sine to theta. Now sine inverse, sine will cancel. So answer is in terms of theta. So do not directly differentiate with respect to theta. You have to substitute back. This is your answer, but you have to write it back in terms of x. So this was the substitution. No? So if x was sine theta, theta is how much? Sine inverse of x. So write it back. And now find the derivative. And you know what is derivative of sine inverse of x. Look into the table, derivative of sine inverse. Okay, and write the answer. It is simple x, so straight away it will be answer, no taking extra derivative and all. So dy by dx will be 2 and sine inverse x derivative is 1 minus x square. So answer is 2 upon root of 1 minus x square. You can try second one. Tan inverse of x upon root of 1 minus x square. Okay, second one, tan inverse of x upon root of 1 minus x square. It is same like first one only. It is in the form of 1 minus x square. So same substitution, let x be equal to sine theta. So what will be theta? Sine inverse of x will be equal to theta. So write the function. You can take this as y. Huh? Even if they don't give y, you have to consider it to be y. Now write back in terms of sine theta.
One upon square root of 1 minus x square.
What you are getting first answer, meaning before this, finding the derivative. Sine inverse of
Theta.
x, no?
Yeah.
Okay, correct. Okay, so that will be tan inverse of sine 1 minus sine square theta. This is simple one. Okay, so 1 minus sine square theta, just now we did, that is cos square theta. Then root and square will cancel. Then it will be sine theta upon cos theta, which is nothing but tan theta. Okay, so y is nothing but theta, and which is nothing but sine inverse of x. And then find the derivative. Dy by dx is equal to sine inverse x formula is 1 minus x square. Okay. Next question had come in one of the board papers for 3 marks. Just to give the question. Third one, if sine of 2 tan inverse 1 minus x upon, prove that dy by dx is equal to minus x upon root of 1 minus x square. So this had come for 3 marks. If sine of 2 tan inverse so it is in the form of root of 1 minus x upon 1 plus x. So what will be the standard substitution? What to take? X as yes, cos theta. Okay, so let x be equal to cos theta. Okay, so you can consider this to be y later on when you are finding. You can consider y. Y is equal to this, find the answer. Now your substitution is let x be equal to cos theta. So theta is what? Cos inverse of x. And now substitute 1 minus cos theta upon 1 plus cos theta and solve. Write the function back in terms of cos theta and try to simplify. So y will be sine of 2 just now we had done the formula. What is 1 minus cos theta? If it was 2 theta, then it would have been sine square theta, but this is only theta. So half it will
Theta by
become.
2.
So answer will be 2. Yes, so sine square theta by 2. Same way this will be 2 cos square theta by 2. And then simplify. Two and two will cancel. Then square. So it will become 10 square theta and its root will become 10. So directly 2 tan inverse of 10 theta upon 2. Now 10 inverse and 10 will cancel. I skipped one step on that I should know. It will become 10 square theta root n square will cancel and this will be straight away tan theta. Now again what will happen? 2 and 2 will cancel. First tan inverse, tan will cancel, and then when you write the next step, 2 and 2 will cancel. So what you will get is sine of theta, no? So y is sine theta. Don't directly write dy by dx is cos theta and keep. Don't differentiate till you write it back in terms of x. So if you do resubstitution, theta was nothing but cos inverse of x. And now this inverse is inside the bracket. So follow triangle method and find the answer. This you have to follow triangle now. So you take any other letter. Theta you already took. Can take A. So adjacent upon hypotenuse. This will be 1 minus x square. Okay, so what will be sine theta? Nothing but opposite upon hypotenuse. Okay, triangle method again and again I'm not repeating, is the same thing. But now you all should know how to solve. So y is 1 minus x square. Now find the derivative. So dy by dx now. If you notice, this is root something. So what is derivative of root? 1 upon 2 root. Okay, and then extra derivative of this. What is the inside the bracket? So derivative of 1 is 0. This will be derivative of x square will be minus 2x. 2 and 2 will cancel. That's why I'll get your answer as, which is equal to your right hand side. If anyone has doubt, then ask. Root of something is 1 upon 2 root. Extra derivative of what is there inside the bracket. More problems on substitution I'll solve later on. It is then higher order derivatives. Okay, so that time directly I'll solve. Because if I do now and again solve there, it will be waste of time. So right now in this simple category, only these were there. Later on many will be solved on substitution. Next is based on this formula, tan inverse x plus or minus. Ulta I will write, wait. Okay, plus or minus. So based on this formula from inverse trigonometry, tan inverse of x plus or minus y will be equal to tan inverse of x plus y upon 1 minus xy. If this is plus, this will be minus. If this is minus, this is plus. Okay, so again the question is find dy by dx. First one, 9x upon okay, there will be a combination of numbers, tan inverse of something like this. Then whenever there's some numbers or something included, you will know that it will fall in this category. Okay, so I have to try to bring it in this form. X plus y upon 1 minus xy. But there's only one single term here. I have to split it as two terms in such a way that I have to find what is value of x and y. So this 20, split it in such a way that those two numbers will give you, same like factorization, it will give you 20 and the combination should give you 9. So first example, it will be like this.
4 and 5.
Yes, or 5 and 4. Okay, 5 fours are 20 and it is plus and plus only. So both will be plus. So now split this as tan inverse of 5x plus 4x. And this will be again 20. See now this is x square. So it will be 5x into 4x. Split this as 5x plus 4x and 20x square 5 into this. So 5 4 are 20. X into x will give me x square. So this is the way it has to be splitted. Now it will fall in this category, tan inverse of x plus y upon 1 minus xy. So what is the in place of x? 5x. What is the in place of y? 4x. So apply this formula here. So what it will do? Tan inverse of x. Since this is plus, this will be plus. Okay. Anyone having doubt? Ask. Now differentiate, find a derivative. Now you know what is derivative of tan inverse of x. Till here, if anyone has doubt, can ask. I've split 9 is x plus y into 1 minus xy. This part is x, this part is y. So accordingly, I've written the answer. And now take the derivative. So that will be dy by dx will be tan inverse of this 1 upon 5x square into extra derivative of 5x. So that will be 5. Okay. So you have to take derivative of this plus this will be 1 upon 4x the whole square into 4. So that will be how much? 5 upon 1 plus 25x square, 4 upon 1 plus 16x square. Those who are finished can try this. Cot inverse of 35x square upon 2x. So the hint over here is this is in terms of cot. So first make it ulta, tan inverse. So this will become ulta. 2 will go up and 1 plus 35x square will come down and then split. So y will be tan inverse of ulta I made. So that I can use tan inverse of x plus y or x minus y formula. Now split 35 in terms of two numbers. So which combination you are getting?
Seven and five.
Yes. So it will be 7 minus 5, no?
The answer is 7 upon 1 plus 49x minus 5 upon 1 plus 25x square. Correct?
Yeah, correct. So 35 is splitted as 7, 5. Okay. So since I want to get 2, it will be minus 5. So 7x so answer will be, this will be tan inverse of 7x. Since this is minus now, so when you take derivative, it will be 1 upon 1 plus 7x the whole square into 7, and this will be 1 upon into 2, and then 7 upon square will belong to both the terms. So this way. Third one, cot inverse of 2 plus x upon 2
Teacher,
minus x.
Teacher, it is 5. You have written 2.
Here 5.
Teacher.
Just correct those have written as 2. Third one is 2 plus x upon 2 minus x. So first reverse. And make it tan inverse. Now third one, y will be tan inverse of Mute the phone. Okay. So now this will be, it is not in straight in the form of x. It should have been what? Here there should be 1 always. X plus y or like this. If it is minus, then this will be plus. So always if you want to apply the formula, you should notice that here it should be 1. Here it is not 1. So first try to make this 1. So divide numerator and denominator by 2. Why is it? Because if you see in the previous 2 problems, there was 1 automatically over here. But now in this case, there is no 1. So just divide it by 2. So that is becomes 1. Not this. So don't worry. For this number first. Because I want this term as 1. So when you divide, all the terms will get divided by 2. So y will be 1 minus x upon 2 . So if nothing is there, it means what? Like 1. Correct? So x value is how much? 1. Y value is how much? X upon 2. So x minus y into 1 plus xy. So this will be tan inverse of 1, tan inverse of x upon 2. And now take the derivative. So what will be tan inverse of 1? Pi by 4. Or directly also if it's a number, tan inverse 1. So straight away answer will be 0. And this will be x upon 2 the whole square into derivative of, so into half. I'll write there if you can't see. So dy by dx will be, this is pi by 4, so it will be 0. 1 upon into derivative of x upon 2 will be half. Now you solve, simplify. So x upon 2 the whole square will be x square upon 4.
Two upon 4 plus x square.
Yeah, minus is also there. This minus will be left. Okay. So this will be 1 plus x square upon 4 into half. So when you cross multiply, it will be 4 plus x square upon 4. So one step you can skip, and then when you reverse, 4 will go directly up. Okay. And then you can cancel, and this will become minus 2 upon 4 plus x square. So this simplification, I cross multiplied, 4 will come to the denominator. And you take denominator, it will go straight up here. Then it will cancel, and minus 2 upon 4 plus x square will be your answer. Fourth one, I can try this. Tan inverse of ax minus b upon a plus bx. Fourth one. So you'll make that term 1. Divide numerator and denominator by a now. This term I need as 1. So divide numerator and denominator by a. So all the terms will get divided by a. So it will be tan inverse of ax upon a will be only x will be left. Okay. And now already it is in the correct form. X minus y into 1 plus xy. That will be tan inverse of x, tan inverse of y. So you can consider as y.
1 upon 1 plus x square.
Yes. Derivative of, don't take, those who ever do like this, it will be wrong, huh? Tan inverse of b upon a, if you write like this, it will be completely wrong because there is no x term at all. B upon a is nothing but a constant, some number. So whenever there's a pure number or any letters without x, so that will be, answer will be straight away 0. So this is wrong. So answer will be only for this one. That will be 1 upon 1 plus x square minus 0. This is dy by dx. And the last one on this, fifth one, tan inverse of 3 minus 2 tan x 2 plus 3 tan x. Tan inverse of 3 minus 2 tan x upon 2 plus 3 tan x. Again, we have to make this 1. So divide numerator and denominator by 2. So y will be tan inverse of 3 by 2. 2 and 2 will cancel. This will be 1. So you will get like this. When you divide all the terms by 2, this is how you will get. 2 and 2 will cancel in that second term. So it is already in the form of x minus y. This is plus, no? So 1 plus x into y. So this is like your x and this is y. So tan inverse of x minus tan inverse of, what is the in place of y? Tan of Okay, tan inverse of this whole thing cancels and only x will remain, and derivative will be, this is a pure number, so straight away answer will be 0 and this will be 1. So answer will be -1. Okay, so these were the problems based on tan inverse formula. Next, I'll start with logarithmic functions. Or logarithmic differentiation. Okay, so when do you know that you have to solve it by logarithmic differentiation? So this is done when you have to find derivative of some function, okay, raised to another function. Also, like this, I will write it. Function raised to function. Till now, we are done with function raised to number or number raised to function. This is what function. Okay, anything in terms of x is called as a function, and this is raised to number. This was the derivative was what? N x raised to n minus 1. This is what? Number raised to function. This was what? A raised to x log a. But now this type will be like this, some function raised to function only. In that case, there's no direct derivative for x raised to x, formula is not there. You cannot write it as x times x raised to x minus 1. This is wrong. Okay. Only if there's a number here, you can apply, but not with function raised to function. In that case, you have to follow logarithmic differentiation. So there are two steps which you have to follow. In this case, step 1 is take log on both sides first. And then step 2 is to differentiate with respect to x. Okay. So these are the two steps. First take log and then find the derivative with respect to x. It means what? D by dx you have to find. So I'll start with the first problem. The question is find dy by dx. So first is y is equal to x raised to x. So now if you notice, this is function raised to function. So follow the first step, right? Taking log on both sides. This you have to write, log on both sides. So when you take log on both sides, it will look like this. Log y is equal to log of x raised to x. So whatever the question given, if it is function raised to function, straight away take log on both sides. Now, if there is any power here, always it will come out here. You know that. Here, x raised to anything which is there, you can remove it out over here. So log y, it will be like this. X log x. Now your first step is done. You took log on both sides. Now step number 2. So this was step number 1. 2 is differentiate with respect to x. Or I can write just diff, okay? Even for exam, if you just write diff, it is okay. To differentiate with respect to x. So now you have to find derivative of this. Now log of something. What is derivative of log x? 1 by x. But instead of x, it is y now. We are differentiating with respect to x. So what is derivative of log y? It will be 1 upon y. But is it x? No. So extra what you have to take? Derivative of this y. So dy by dx. Anytime if you problem, if you come across with respect, suppose if there's a y function, and if you are differentiating, same like x only you have to solve, but only extra you have to write dy by dx, because it was not x. Instead of x, it was y. That's why extra derivative of dy by dx. Okay. Anyone has not understood, then ask. Log x would have been 1 by x straight away, but this is instead of x, that is the letter y. So that's why extra derivative you have to take. And this is now straight away, we cannot write it as 1 and this. It is in the form of what? U into v. U and this is v. So what is u into v formula? U into derivative of v plus v into derivative of u. So write u as it is. Now I'm not writing formula again anything, because from here onwards you have to learn how to directly write the answers. So u write as it is, x into derivative of log x. So what is derivative of log x? 1 by x plus v into derivative of u. Derivative of x is how much? 1. Okay. So this is how it has to be solved. U into derivative of this one plus v into derivative of u. X and x will cancel. And now this y which was there over here now, bring it this side now. I want to find only what dy by dx is been asked to find. This extra term I don't want here. So it is at the denominator here. When you take it this side, it will come to the numerator. So what will be dy by dx? Y will come this side. So it will get multiplied. Okay, so like this you will get. And now one last step. Everything should be in terms of x now. So what was the function given to you? What was the question? Y is nothing but x raised to x. So just substitute here back. So dy by dx is nothing but. So this is your answer. Okay, so take y on the other side and substitute the same thing what was there in the question. So as they're finished, can attempt the second one. First one, anyone having doubt, then ask her. X e raised to x. So this is like function is to function. So straight away, take log on both the sides. So taking log on both sides, it will be log y, log of like this. And now this power, whatever is the power of x, will come out. So it will be e raised to x and now find a derivative. Differentiate on both sides with respect to x.
Log x is to ex into the bracket e raised to x upon x plus log ex raised to x.
Log x into e raised to x, no? Last term. Okay. So when you take different derivatives, same like now everywhere it will follow the same. Log y is nothing but 1 upon y into extra dy by dx. This is u and this is v. U into v rule. U into derivative of v. 1 by x plus v you write as it is. What is derivative of e raised to x? E raised to x only. Okay, so that will be our answer. Just take y on the other side and substitute. E raised to x I just wrote first. Okay, and then substitute. So x so this will be our final answer. Okay. One more way you can use this log if there's some complicated function, suppose x cube sine 4x upon e raised to 5x into sec of x. If there's another complicated function like this, you can use log to simplify it. Okay, so this is multiplication, this is multiplication. What you do is take log on both sides. So log y will be log of x cube e raised to 5x into sec of x. Now you all know the formula. What is log of a into b? Log of a into b is log of a plus log of b. And if anything is at the denominator, it is minus. So you can split this as log a plus, multiply means plus, it will become log b. Since this is at the denominator, it will be minus log e raised to 5x minus log of sec of x. So applied log to all the terms. A into b, numerator into means plus, denominator upon means minus. And now differentiate. So find derivative of all the functions. So this will be as it is, 1 upon y dy by dx. Now log of something, log of x cube will be 1 upon x cube into extra derivative of this. So 3x square. Same way, log of this whole bracket will be 1 upon this full thing into derivative of sine 4x. So what will be derivative of sine? Cos 4x into derivative of 4x. So that will be 4. I'm solving this composite function way. Log of bracket will be 1 upon that. Then take derivative of this cos. Then derivative of inside the bracket. That will be derivative of 4x will be 4. Then minus log of that will be 1 upon e raised to 5x. And right here. Into what is derivative of e raised to 5x? E raised to 5x only. And again 5. Then 1 upon sec x. Derivative of sec of x is how much? Sec of
Sec
x
x 10x.
10x. Yes. And now simplify and write the answers. So what will happen? X square will cancel with 3 of, only one x will remain. E raised to 5x, e raised to 5x will cancel. Sec of x will cancel. And now write the final answer. So in short, if there are complicated functions like this, you can always use log and simplify, split this, and then find the derivative. So the answer will be dy by dx. Y you take on the other side. Here 3 upon x will remain. Cos 4x upon sin 4x will become cot. Minus 5 minus 10x will be your answer. And last you substitute y from the question. So the whole question will come again over here. So that will be your answer. Okay. The last one. Y is equal to x raised to sine inverse of x. So taking log, so this will be log of y. I'll skip the step. It will be like this. First step, directly can write like this also. Sine inverse will be here. Then I brought it out. And then differentiate. So it will be 1 upon y dy by dx sine inverse of x u into derivative of v plus v into derivative of u. Sine inverse x will be 1 upon 1 minus x square. Okay, and then dy by dx. Y, if you take other side, directly you can substitute. What is y? Nothing but x sine inverse x, sine inverse of x upon x, log x upon 1 minus x square. Okay, so this will be your answer. So I will stop here. I'll say tomorrow I will not take a class. Huh? I'll send some problems for you all to practice on whatever I've solved till now. Just wait and take attendance. Just take attendance. Okay, so tomorrow's class, when I don't take, please go through whatever the basics which I have covered. If anyone having some difficulties and all till now in understanding, then please ask, okay? Because later on, now the problems will be getting complicated. So all these basics, whatever, if you have done till now, if you have understood, later on also it will find very easy. Okay, so now if you have copied, you can leave.